Welcome to Geometry Unit 8 video for skill number 58. I can solve problems using angle of elevation and angle of depression. We'll begin our notes on page 58A, and we start by defining what angle of elevation is. Angle of elevation is the angle formed by a horizontal line and a line of sight to a point above the horizontal line. So in the drawing down here, we've got the horizontal line at eye level for the person, and when they look above the horizontal, then they're going to create an angle of elevation. So A is our angle of elevation. The angle of depression is the angle formed by a horizontal line and the line of sight to a point below the horizontal line. So when we're looking down, we create the angle of depression. So in the provided picture, the person standing on the edge of the cliff, when they look up to the plane, that's an angle of elevation. And when they look down to the boat, that's an angle of depression. If I were to add another person sitting in the boat, we'll say they're sitting in the boat right there, and their line of sight is horizontal. If they were to look up at the person, that would be an angle of elevation for the person. So we have to keep in mind that the angle of elevation and angle of depression is dependent upon the observer. So for this person here to look down at the boat, it's an angle of depression. But for the person on the boat to look up at the cliff standing person, that's an angle of elevation. I'll walk us through two problems that use angle of elevation and angle of depression, and we'll start at the bottom of this page with example 1. So, example 1. When standing 15 feet away from a statue, the angle of elevation to the top is 20 degrees. If my eyes are 5 feet off the ground, how tall is the statue? So let's just draw a quick sketch of that. Here I'm standing, my eye line is 5 feet off the ground, because I'm just over 5 feet tall, and I'm looking at some sort of statue. And the statue has an angle of elevation that is 20 degrees. So our goal is to find out how tall is the statue. So if you think about it, what we've done is we've created a right triangle that looks much like what I've drawn in the red here. And we're going to be looking for the dimension of this side, but that doesn't tell us everything. That only tells us how tall it is along this line. We need the whole height of the statue, so we're going to add the 5 feet that occurs down here. So on the next page I walk us through the process. Alright, so step 1 for this problem is to draw a diagram. Most of these problems will come in the form of word problems, and then you need to create the diagram based off of the word problem. And sometimes they'll give you the diagram and you just need to label the key features, such as what is the angle of elevation, how far off is the horizontal line, etc., etc. As you can see in this drawing, I included my distance to the statue of 15 feet, which my drawing on the previous page did not have. If we take this diagram, what we can do is decontextualize it. That's kind of a fancy word for get rid of all the extra information so that it's just a simple diagram. And now what we have is a simple right triangle, and we're looking for the side opposite of 20 degrees. And using our trigonometric ratios, we know, if we think back to our trig ratios, we have SO, CA, TOA, and in this case our known angle is 20 and our sides that we're looking at are opposite and adjacent. So tangent uses opposite and adjacent. Tangent of 20 is x over 15. And so we use our trig ratios and we're able to solve for x, and we find x is approximately 5.46 feet. That isn't the final answer though, because we're looking for the total height of the statue. So we have to add 5.46 and 5 to get our total height for the statue. And I kind of call that recontextualizing. A lot of times you can do it without drawing the diagram, but in the end, the statue is 10.46 feet tall. Example 2 says the angle of depression from a fighter pilot to an enemy target is 17 degrees. It also tells us that the pilot is flying at an altitude of 4,000 feet, and we want to find out how far away the target is. So if we were to diagram this situation, what we have is we have some sort of airplane that's a fighter pilot is flying in, and when he looks down at the enemy target, it is at an angle of 17 degrees with the horizontal. And the other piece of information they give us is that he's 4,000 feet above ground. His altitude is 4,000 feet. So what we're looking for is the distance to the enemy target. Maybe it's a house. All right. So this is the rough diagram based on the example. I'm going to go ahead and slide the page up so that we can walk through the process. All right, so in the diagram I've labeled all the important pieces, and as I said, what we're looking for is the distance between the pilot and the enemy target. So here's our contextualized drawing, and we can remove all the context and just turn it into a right angle triangle. And again, we use tangent because the sides of interest are 1,000 and x. Now you'll notice that what I've done here is I created this angle down here was 17, whereas up here it was the angle above. And we can do that because our horizontal vision line is parallel to the ground. So what we have is a case of alternate interior angles. This angle here is alternate interior to this angle here. So we're able to say it's 17 degrees. From there, we're able to use tangent of 17, and our opposite is 4,000, and our adjacent is x. And multiply both sides of that equation by x and divide both sides by tan 17. And we get a distance of approximately 13,080 feet. As you work through more of these problems, you'll notice that using the tangent trig function is actually very common for several of these angle of elevation and angle of depression problems. I don't want to say it's used for all of them, but it's very, very common that tangent is the trig function which best suits the question. All right, the key concepts and ideas for this skill are being able to identify your angles of elevation or angle of depression. So if you're given a diagram, you should be able to label which ones are angles of elevation versus angles of depression. Ultimately, this leads to questions where you're solving right triangles based off of information you are given. And finally, we need to be able to draw from a word problem. So when we're given a description of a scenario, we should be able to generate a rudimentary drawing of what's going on to help guide us in solving the problem.